Good morning to everyone. Good morning. Okay, so we will start with the class. That means whatever I have taught in the last class. So I will briefly explain that one. So if you remember, can anyone can put the points or can write the points? Which are those concepts we have discussed? Which were those concepts which we have discussed? So that is electropositivity, then with respect to electron gain enthalpy, right? So these are the two concepts which we have discussed. One is electropositivity and another one is electron gain enthalpy. So now one thing I will make it clear. When I am talking about enthalpy, as we have discussed, it is nothing but heat content or energy. Okay, that's where we have the enthalpy. So which can be symbolized as H, capital H. Symbol is for enthalpy is capital H. Now whenever I am writing delta H, so that means I am talking about change in enthalpy. Okay. Say for example, with respect to Raghavendra sir, if you consider me as an example, what is the energy content in Raghavendra sir before starting the class and after starting the class, after finishing the class? So before starting with the class and after finishing with the class, what is that energy difference? Right? With respect to Raghavendra sir. So that means there is a change in energy. It cannot be same. There will be change in the energy. So that's why this delta indicates, all of you know, that is related to change. In a process, in the beginning, what was the energy content? After the process, what is the energy content? So that's what delta H talks about. So therefore, electron gain enthalpy can be represented as delta EgH, where Eg stands for electron gain. Okay, so change in electron gain enthalpy. So that's where we have the symbolic representation for electron gain enthalpy. All of you have understood? So what is that capital H? Capital H is nothing but enthalpy. So delta indicates change in enthalpy. So that's where we have the electron gain enthalpy. All of you have understood? So when it comes to electropositivity, it is nothing but ability of a element to donate the electron or to lose the electron. Element to lose the electron. So that is nothing but electropositivity. Opposite to that of the electronegativity. Okay? So that's where in case of the electronegativity it was attraction, ability to attract. But here it can lose the electron. So that's where we have the electropositivity. Fine? Now, when it comes to metals and non-metals, that's what we have discussed. When it comes to metals and non-metals, all of us will know metals are present on the left side of the periodic table and non-metals are present on the right side of the periodic table with respect to their location in the periodic table. Okay? So what I mean to tell here is non-metallic character will increase when you move towards the rightward direction, and metallic character will be increasing when you are moving in the leftward direction in the periodic table. Fine? All of you have understood? That is one thing. Now when it comes to metals, they are electropositive in nature. They are electropositive in nature. That's where we have the electropositivity. So due to that, alkali metals, alkaline earth metals, they are all highly electropositive metals, even compared to transition metals. Fine? So that's where we have the electropositive character of the metals. Due to alkali metals, which are on the extreme left side, so due to that, they will be having highest metallic character. Okay? So now, as yesterday, I think Shri Vidya or someone had told, so francium, which is actually a highly electropositive metal or element, but since its radioactivity it is there, we can consider cesium as the electropositive element. But otherwise, francium would have been electropositive element. But now, one thing you should remember, in redox reaction we are going to discuss this one. We have one metal or element called as lithium, which belongs to alkali metal. When it comes to donation of electron, lithium is also a very, very good donor of electron. Please remember. Okay? So that's where we have the redox potential. Okay, anyway, I will not go in detail. So what I mean to tell you is there are many things which are going to decide how an element can donate the electron easily. Fine, but for time being, we can go with alkali metals as highly electropositive metals. In that, yes, cesium we can include, okay, which can be highly electropositive. Now if you come to the periodic table, all of us we know atomic size is going to decrease when you are moving rightward direction, right? So that means metal should be of larger atomic size. Metal should be of larger atomic size. Exactly opposite for the non-metals. They will be electronegative. They will be electronegative, where halogens like fluorine is highly electronegative. Next comes the oxygen, then chlorine and nitrogen, and all the other halogens which are highly electronegative in nature. But fluorine is the one which is having highest value. So now, naturally they should be smaller in size. They should be smaller in size. Why? Because when you are moving in the rightward direction in the periodic table, atomic size is going to decrease. So therefore, non-metals normally it will be, or always it will be, smaller in size compared to the metals. All of you have understood? So that's what we have discussed with respect to electropositivity in the last class. Fine? All of you have understood? Now, when it comes to electron gain enthalpy, now I am coming to electron gain enthalpy. What do you mean by that? It is nothing but ability of element to accept the electron, not attracting, accepting the electron. Try to differentiate those words, identify those words. They are crucial words. When I am telling electronegative, I am talking attracting. I am not telling accepting. But when I am talking about electron gain enthalpy, I am telling accepting the electron or gaining the electron. Better you can use the same word which is here. Gaining the electron. That is nothing but accepting the electron. Ability of element to accept the electron. Normally it will be done in their gaseous state. That is one thing. So normally it will be done when the elements will be in their gaseous state. Only one reason, because for example if I want to write the reaction, X is a element. Don't think it's a chromosome, biology students. Okay now? So X is a element which is in the gaseous state. Now it will accept the electron and it will become anion. It will become anion. If you see the textbook and all, that's where they will give that one in the form of gas. Now why we have to go for gaseous state of element? because all the elements are not in gaseous state, right? So many of them, they will be in non-gaseous state, but still, whenever we are defining electron gain enthalpy, we will talk about gaseous state of the element. Fine, but still they should be in ground state only. Electrons should be in their original energy level only. But why in gaseous state? The reason is very simple. All of us, we know that any molecule which are in gaseous state will have least intermolecular interaction. In gaseous state, they will be having least. In gaseous state, they will have the least or negligible, least interatomic interaction. Interatomic interaction means one atom will have minimal interaction with another atom. So due to that, we are going with the gaseous state. That thing you should remember. Okay na? So due to that, we are going with the gaseous state. Otherwise, what will happen? If there is an interaction between the two elements, now we are talking about removing of electron or gaining of electron. Now what will happen? That can be due to this nuclear force or this nuclear force, which will also impart for that electron to taken easily. Chances are there. Even neighboring nuclear force can also help in gaining the electron. Right? So in that case, we are not justifying for only that element. So due to that, we are going with the gaseous state where there will be least interatomic interaction and where atoms will be a bit far from each other. Right? All of you have understood? That can be the equation by which we can represent the electron gain enthalpy. So that's where this particular equation will have one particular value. I will mention that one as Y kilojoules per mole, not WHY. Y kilojoules per mole, some amount of energy. Fine? Since it is getting released, we will mention it as minus. Since energy is getting released, we will mention it as minus, negative value. All of you have understood? So naturally, in the periodic table, when it comes to electron gain enthalpy, can anyone tell me which are those elements can have positive electron gain enthalpy? Can anyone? Which are those elements which will have positive electron gain enthalpy value? Yes, very good. It is noble gas, group 18. That means noble gas will have the positive electron gain enthalpy value. Very good. Right? Now, can anyone tell me which are those elements? Which are those elements? Ashish, you can write it as noble gas. Okay, na? So, in that case, when it comes to other elements which can have the highest electron gain enthalpy value, that means highest negative electron gain enthalpy value. Which can be those elements? Guess. Which can be those elements which will have the highest electron gain enthalpy value with respect to negative value I am telling. Okay, helium, Ashish, that is answer for first one. First question. Now the question here is, which can be those elements which will be having highest? Very good. That will be chlorine. Yes, when it comes to periodic table, chlorine is the one having highest negative electron gain enthalpy. What do you mean by that? Highest negative electron gain enthalpy means chlorine is the one which can accept the electron easily. In general, if you want to tell, halogens will dominate with highest negative value. Halogens will dominate with highest negative value. Which can be those elements with the least negative value? Can anyone? Which can be those elements with the least negative value? Halogens will be with high negative value, and among that chlorine is the dominating one, right? Now when it comes to other elements, which is that which is having least negative electron gain enthalpy value? Yes. Which can be those elements which will be having least negative electron gain enthalpy value? Very good, Ashish. That should be alkali. So alkali metals are the one. Alkali metals are the one which will have the least negative electron gain enthalpy value. That means they are poor acceptors of electrons. They are poor acceptors of electrons. All of you are absolutely correct. So if I want to give some values, right? So alkali metals values will be ranging somewhere around minus 30 to minus 50. Some values I am giving kilojoules per mole. Kilojoules per mole. But if you see the halogens, it will be ranging from somewhere around minus 200 to minus 300 kilojoules per mole. That is the difference between alkali and halogens. Halogens are very good acceptors of 1 electron. Fine? All of you have understood? So why noble gases are the only elements which have positive value? Because of the completely filled outermost energy level or completely filled shells. There is no place, there is no empty orbitals in case of the inert gas. Okay? So therefore they are very poor acceptors of the electron. All of you have understood? Another 2-3 points are there which we have to finish it off today. We will finish this chapter today. Fine? All of you have understood? Okay? So shall we move to the next one? So electropositivity, it is done. Electronegativity, it is done. Then electron gain enthalpy, it is done. Okay? So now we will move to ionization. Ionization enthalpy or ionization energy. So now we will move to ionization enthalpy. Okay, na? So that's where it can be represented as delta IH. It can be represented as delta IH. Delta EGH meant for electron gain enthalpy. So this is ionization enthalpy. Fine. Hagadre, when I am talking about ionization enthalpy, that is nothing but it is the amount of energy. If I want to define, it is the amount of energy required or applied, required to remove the electron, from a atom in its gaseous state, or okay, I will write atoms, to remove the electron from a atom in its ground state. Here I will mention gaseous atom in its ground state. Okay? So that's where we have the ionization, amount of energy required to remove the electron. Yes, that is also fine. You can remove the amount of energy required to remove the electron from an atom. You can stop there. Or if you want to be more specific, then you can write it is the amount of energy required to remove the electron from a gaseous atom in its ground state. Fine? So that's where we have the ionization energy or ionization enthalpy. That means if I want to go with the equation, I have the element. Now there will be removal of electron. Since one electron has been removed, it will gain one positive charge. When it comes to electron gain enthalpy, where element was converted into anion. When it comes to ionization enthalpy, where atom is getting converted into cation. So atom to anion in case of the electron gain enthalpy, atom to cation in case of the ionization enthalpy. All of you have understood? So for this there will be some ionization enthalpy value. Okay, and the unit will be same as that of the electron gain enthalpy, that is kJ per mole or kilojoules per mole. That will be the unit. Same thing, Achyuta. So kilojoules per mole only, because we are talking about enthalpy, energy, right? So therefore it will be same, kilojoules per mole. All of you have understood? That's where we have the ionization enthalpy. Now, if you recollect whatever we have discussed with respect to electron gain enthalpy, if you recollect whatever we have discussed with respect to electron gain enthalpy, fine, where two elements, although they were highly electronegative, electron gain enthalpy was less. Which were those elements? We had two elements where they were having high electronegativity, but still electron gain enthalpy value was less. That's why chlorine is getting dominated. Which were those elements? Which we have discussed in the last class. Which were those elements? Yes, fluorine and even oxygen, right? So that is because of their small atomic size. Due to their small atomic size, yes, you people are right, that is fluorine and oxygen, right? So due to their smaller atomic size, what will happen? There will be electron repulsion will take place. So therefore they cannot take up the electron. But due to their smaller size itself, they will be having highest ionization enthalpy also. Due to their smaller size, they will be having highest ionization enthalpy also. All of you have understood? Any doubts? They will be having higher ionization enthalpy value also. Which one? Fluorine and all. That is due to their smaller atomic size. That is due to their smaller atomic size. All of you have understood? Even noble gas will have the high ionization enthalpy value. Even noble gas will have the high ionization enthalpy value. So that's where we have the important term. But there is one variation. There is one thing which is variable here. It's not uniform. Whatever value is there, it's not uniform. Normally, if you go with ionization enthalpy value in the periodic table, how it would have been? IE stands for ionization enthalpy. So now, when you are moving towards the rightward direction, ionization enthalpy value should increase or it should decrease? It should increase. Ionization enthalpy value will be increasing. When you are moving downward direction, what will happen to the ionization enthalpy value? It's going to decrease. It's going to decrease, right? When you are moving downward in a group, ionization enthalpy value is going to decrease, and when you are moving to the rightward direction, it's going to increase. All of you have understood? That's all because of the variation in the atomic size. That's all because of the variation in the atomic size. So that's where we can see ionization enthalpy is going to increase when you are moving rightward, and it's going to decrease when you are moving downward direction. Fine? But when these changes are there, they are not uniform. That's what I mean to tell. If you plot the graph where ionization enthalpy and across the period, if you take across the period, when you are plotting the graph, naturally it will be something like that. It is not like it will not give a straight line. No, it will give the variation. There will be some variation. Now, can anyone write the electronic configuration for boron? Can anyone write the electronic configuration for boron? What is the atomic number of boron? 5. Atomic number of boron is 5. So can any one of you write electronic configuration for boron? Okay. Many of you have written 1s2, 2s2, 3p1. Okay, fine. Very good. So I will use the helium. That is 1s2, it is done. Naturally, next one will be 2s2. Then comes the 2p1. Absolutely correct. Right? So that will be the electronic configuration. Can any one of you write about beryllium? Neighboring element. 4. Beryllium. So that means it will be helium 2s2. Right? So helium 2s2. All of you will agree? So I am concentrating on 2 elements, boron and beryllium. Darshan, absolutely correct. So 2s2, 2s2, 2p1, and for beryllium it is helium with 2s2. Fine? Now, what is that difference you can observe here? Can anyone? What is that difference you can observe here with respect to their electronic configuration? What is that difference in these two? In case of the helium, in case of the beryllium, outermost shell electron is present in the 2s subshell. It is present in the S subshell. Fine? But when it comes to boron, outermost electron is present in the P subshell. Outermost electron is present in the P subshell. That's what we can observe. Here it is in the P subshell. Here it is in the S subshell. Both are with respect to energy level 2 only, because they are in the same period. They are in the period number 2. Now we have one concept called as shielding effect. We have one concept called as shielding effect, which you people might have studied in the atomic structure. Shielding effect. What do you mean by shielding effect? Can anyone? What do you mean by shielding effect? So shielding effect means outermost electron or outer energy level electrons will feel less nuclear force due to the interference by the inner shell electrons. Right? So what is that shielding effect? It is nothing but effect is outermost electrons or outer electrons will have nuclear force, will have or will feel less nuclear force due to the interference by inner shell electrons. That is nothing but shielding effect. Outer electrons will feel less nuclear force due to the interference by the inner shell electrons. Right? So more shells, more ionization, Achyuta. So what do you mean by that? I am not getting what you have written, Achyuta. More shells, more ionization. So here, outermost, oh okay, you want to tell that electrons can be easily removed. Yes, done. So that's fine. But when it comes to ionization, it can go with the negative charge also. Not only cations, it can go with the negative charge also. That is there. Ions can be anions or cations. Okay? So that's where we have the outermost electron will have less or will feel less nuclear force due to the interference by the inner shell electrons. That's what we can see here. Electrons are there and we have one electron. Now this is the nucleus which will be having affinity for these two. Same it will have affinity for outer electron is also. But point here is these electrons, they are not static. They will be revolving. They will be revolving around the nucleus. So what will happen in between? These electrons will be on the way where nucleus will have affinity towards the outer electrons. They will interfere because they will be revolving. Right? Electrons are not static. That is nothing but shielding effect. And one of the factor which is going to decide shielding effect is, can anyone? One of the factor which is going to decide shielding effect is shape of the orbital. That is shape of the orbital. If you talk about S, we have spherical shape, all of you have studied. If I talk about P, they have the dumbbell shape. If I talk about D, they have the double dumbbell shape. Now if I observe, anyway, F is not required, it's a complex structure. Now when it comes to these three, if you consider, we can see electrons present in the S subshell, they will be at uniform distance from the nucleus. There is no variation. They are in the uniform distance from the nucleus. There is no variation. But here, there is a variation. So once electron will be near to the nucleus and once again it will go away. It will near to the nucleus, once again it will go away. So there is a variation. They are not at constant distance from the nucleus. And here much more variation is there. Because electrons will be here, then they will come here, once again they will go away, they will come, once again they will go away, they will come and once again they will go away. So lots of variation when it comes to D. And in F, it will be much more variation. So what I mean to tell you is, S subshell electrons are the one which are near to the nucleus, which are at constant distance from the nucleus. So therefore, listen to me carefully. Therefore, S subshell electrons will feel more nuclear force. S subshell electrons will feel more nuclear force compared to any other subshell electrons. Compared to any other subshell electrons. Once again I will repeat. So due to that, S subshell electrons will feel more nuclear force compared to other subshell electrons. Or I can tell that S subshell electrons will be having shielding effect on the other subshell electrons. S subshell electrons can have the shielding effect on the other subshell electrons. All of you have understood? Any doubt? So that's where we have the shielding effect. You have to understand this concept. Fine? So all of you have understood? Any doubt? Now if you observe beryllium, we have the outermost energy level as 2 and where electrons are present in the S subshell. When it comes to boron, energy level is 2 only, but outermost electron 1 is present in the P subshell. So that means removing of electron from here, it will be a bit difficult compared to here. Fine? Why only electrons who are present on the last shell where participate in the acts? Okay, so what I can guess here, why, and what I have understood from your question here is, you want to ask that why outer electrons only? That is your question, right? So now, not only outer electron, when it comes to shielding effect, it can be any of the electrons, even this electron. Now outer electron is this one. Even here we can talk about shielding effect. All the electrons will have the shielding effect on the next energy level electrons, no doubt. But outermost electron is the one which does not have any shielding effect on any other electron because nothing is there. This is the last electron. Got my point? And why we are focusing on outer electron? Because they are the one which are involved in the interaction. They are the one which will be donated. See, for example, when I am talking about sodium, which is getting converted into Na+. So now, during that time, it is the 3s1 which has become 0. Not the inner shell electrons. It is the outer electrons which will be donated. Fine? As it is easier to lose the outermost electron. Yes, Ashish. So due to that, since outer shell electrons are the one which are involved in the reaction, when I am talking about ionization enthalpy, always it is about the outer electrons which will be removed, not the inner electrons. Fine? So due to that, we are talking about outermost electrons or valence electron. Fine? Otherwise, shielding effect can be shown by inner shell electrons on the next energy level electrons, no doubt. It's not applicable only for the outer electrons, no. It's applicable for all the energy level except inner shell. Because for inner shell, innermost electron, nothing is there to show the shielding effect. But outermost electron cannot show shielding effect on any other electron because nothing is there. Outermost electron is the last one. So therefore, shielding effect is applicable for all the energy level except outermost energy level and innermost energy level. For all the other energy level electron, shielding effect is applicable. But we will be interested in valence electron. Fine? Because that is the one which is involved in the reaction. So what I mean to tell you is, that's where we can see, although depending on the atomic size, if I want to go, beryllium is somewhere here. Okay? Beryllium. So when I am talking about boron, that is group 30. Boron, group 30. Now if I observe, boron is having atomic size less compared to beryllium. Beryllium is alkaline earth metal. Boron is a p block element. Still, ionization energy for boron is less compared to beryllium. Or what I can tell here is, we can remove the electron from boron easily compared to beryllium. There is a variation. Right? So it's not exactly following the atomic size. There is a slight variation. Why there is a variation? The reason is due to the electrons, electron configuration. Where electrons are present. Here it is present in the p subshell. Here it is present in the s subshell. So due to that, there is a variation in ionization enthalpy. All of you have understood? So due to that, beryllium should have got less ionization enthalpy compared to boron. But here it is reverse. Beryllium is having higher ionization enthalpy compared to boron. All of you have understood? So the reason is because of the electrons present in the p subshell in boron and electrons are present in the s subshell in beryllium. Fine? All of you have understood? So that is one thing. Can any one of you tell me? Can any one of you tell me any other variation we can observe when you are moving across the period? Any other variation? Why I am asking you people? Because already I have told about this. Any other variation? This is one variation which we can observe. Same way, we have any other variation? Yes, it is there. Then where? Where we can observe the variation? Hmm? So already we have discussed about this particular one, which I am asking. That is, see for example, if I take nitrogen and oxygen, if I take nitrogen and oxygen, now atomic size of nitrogen should be bit larger compared to oxygen. All of you will agree? Right? That is because nitrogen belongs to group 15 and oxygen belongs to group 16. So as we are moving rightward across the period, when you are moving in the rightward across the period, now what will happen? Atomic size is going to decrease. As the atomic size decreases, ionization enthalpy should be increasing. Right? So in this case, it's not happening. Nitrogen will be having higher ionization enthalpy and oxygen will be having slightly lower ionization enthalpy compared to nitrogen. What is the reason? Can anyone? What is the reason? Or what can be the reason why nitrogen will be having slightly higher ionization enthalpy compared to oxygen? What can be the reason? Anyone? Atomic radius decreases. Yes, Gahan. According to that, if I go, nitrogen should have got lower ionization enthalpy compared to lower ionization enthalpy compared to oxygen, but that is not happening. As it has more radius compared to oxygen. How it's possible, Ashish? Both belongs to period number 2. Outermost energy level will be 2 only. Right? Definitely atomic number of oxygen is more, where it will be 8 and here it will be 7. That means more nuclear force in oxygen. Atomic size will be less, no doubt, but ionization enthalpy will be, that is also a bit less compared to nitrogen. What is the reason? I have told this one. Can anyone? I had explained valency is less, okay, definitely. Oxygen belongs to group 16, 6 will be the valency. Nitrogen 15, 5 should be the valency, fine. But that is not the answer. Can anyone? That is because half-filled electronic configuration in nitrogen. Nitrogen is having half-filled electronic configuration. Please remember, stability, that's what I told. If you write the electronic configuration for nitrogen, that is helium. So helium is 1s2. Still we have to go with 5 electrons, right? Because total 7. So that means 2s2, 2p3. That is for the nitrogen, electronic configuration for nitrogen. If I want to talk about oxygen, it will be helium, 2s2, 2p4. So due to the stable electronic configuration in nitrogen or any of the group 15 element, they will be having slightly higher ionization enthalpy compared to their neighboring element in group 16. Got my point? There is a variation. So in case of boron and beryllium, reason is different. In case of nitrogen and oxygen, reasons are different. There it was due to S subshell and P subshell. Here it is due to stable electronic configuration in the nitrogen. And the same reason is applicable why noble gas have the highest ionization enthalpy. That is due to the stable electronic configuration. inert gas will be having the highest ionization enthalpy. Then comes the halogens. When it comes to halogens, why? That is because of smaller atomic size. But when it comes to inert gas, why? That is because of the stable electronic configuration. They don't want to lose the electrons. Fine? So that's where we have the ionization enthalpy. All of you have understood? Any doubt? Any doubts in this? Okay. Now, one thing I will make it clear. There is one concept called as diagonal relation. Anyway, these things we are going to discuss in detail when it comes to S and P block elements. We are going to discuss in detail. Fine? So that is diagonal relation. You can expect 1 or 2 marks question on this. What is diagonal relation in a periodic table? Explain with example. In that case, I can tell that I have lithium as alkali metal, right? It will have the similar property to that of the magnesium, which is the second element of second group, alkaline earth metal, right? They will have the similar properties. I am not telling same, I am telling similar property. One belongs to group 1, another belongs to group 2. Same way, we have beryllium, which will be having similar property to that of the aluminium, which will have the similar property to that of the aluminium, right? So that means this belongs to period 2, this belongs to period 3. This belongs to period 2, this belongs to period 3. That is one thing. And another thing is, this belongs to group 1, this belongs to group 2. This belongs to group 2, this belongs to group 13. Right? So that's where we have the group 2 and group 13. So here it is group 2 and group 1. Right? So here it is period number 1 and here it is period number 2. So what I mean to tell you is diagonal relation means these two are the best example where element present or first element of one group will have the similar property to that of the second element of the next group. That is nothing but diagonal relation. Fine? What is the reason? The reason is because they will have almost similar atomic size. I am not telling same once again. They have almost similar atomic size. Due to their similarity in their atomic size, they will have some of the property which will be of same. Got my point? So due to similar atomic size, almost same atomic size, lithium and magnesium will have. Same way beryllium and aluminium will have. But not all the properties will be same, but many of the properties it will be same. So what is the reason? That is nothing but due to the similar atomic size. All of you have understood? That is nothing but a diagonal relation in the periodic table. Right? Yes, lithium, magnesium, even beryllium, aluminium, all of them they are metals only. So therefore, these strands are not reproducible in non-metals. Next, elements, it is less reproducible. Therefore, I told these can be the best example. These pairs are the best example for diagonal relationship in the periodic table. All of you have understood? Anyway, you are going to discuss this one in detail when you are talking about S block and P block element in chemistry part 2. You have that one. So, but this is what you should understand what I mean by diagonal relation and example. So, which are those properties that you are going to discuss in detail in S and P block. Fine, that is one thing. Now, always remember that period 2 elements, they will have always a different property compared to the rest of the element in their group. they will be having slightly different property compared to rest of the elements present in the same group or their respective group. So that's where it is called as anomalous. That's where it is called as anomalous properties. That's why it is called as anomalous property. Anomalous means something different, which is not usual, something different. So that's where we have the anomalous properties. So what is that anomalous property? Anomalous property means first element of the group, like group 1, hydrogen is not considered as the first element of group 1, it is the lithium. So group 1, group 2, then group 13 to group 17. Forget about inert gas and forget about transition metal, because transition metal does not have period 2. Transition metal will start from period number 4. So we are not talking about period number 4. We are talking about the element present in period 2. Fine. So therefore, those elements will have different property compared to rest of the element in their groups. So that is called as anomalous property. That's quite natural. That is because all the elements which are in first position in their group, it will be of smaller atomic size. It will be of smaller atomic size. That should be the one reason why they should show the anomalous property. That is due to smaller atomic size. Whether lithium, yes, lithium in group 1 will be the smaller atom. Beryllium, yes, in group 2, beryllium is the smallest one. If I take halogen, yes, fluorine is the smallest one. If I take nitrogen family, yes, nitrogen is the smallest one. So that's what, due to one of the reason is smaller atomic size compared to other element in those groups. That is one thing, reason for the anomalous properties. Which are those anomalous properties? You are going to discuss it in group S block and P block element, don't worry. Here I am just telling the reasons, that is one thing. Now, when it comes to period number 3, which energy level I am talking about? Period number 3, not period number 2. Period number 3, which energy level I am talking about? Anyone? When I am talking about elements present in period number 3, which will be the outermost energy level in those elements? Which is the outermost element? Yes, outermost energy is 3. Very good. Now in that case, all of us we know, when I am talking about period 2, I am talking about energy level 2. All of you are right, it is 3. So where only S and P is available. But when I am talking about 3, there will be availability of D. When I am talking about 4, S, P, D, F. That means once energy level 2 is crossed, rest of the energy level will have availability of the D subshell. So that is the another reason, due to the non-availability. Due to the non-availability of D subshell. That is the another reason why period number 2 elements will have the anomalous property. That is the another reason. This one is important because this concept is present in periodic classification also, and same concept you are going to discuss in S and P block also. Therefore, many times they have asked for your board exam, 2 to 3 marks question. Give reasons for the anomalous properties of lithium. Give reasons for the anomalous property of oxygen. Give reason for the anomalous property of nitrogen. Anyway, nitrogen and all, it's not there. When it comes to P block, you have only boron and carbon. So that can be the reason. Give reasons for anomalous properties of boron. So those type of questions will be there. Then the answer should be smaller atomic size, non-availability of the D subshell. Fine. So these are some of the reasons for the anomalous property. Common thing. Applicable for lithium, applicable for beryllium, applicable for boron, even applicable for carbon. Okay. For rest of the element, you are going to discuss in second year. Don't worry. In first year in P block, only two groups we are going to study, group 13 and group 14. Fine. So by this, periodic classification of element is done. Fine. Any doubt? Anyway, tomorrow we are going to discuss some of the CET, NEET and IIT JEE questions on this topic. That is one thing. But before going for that, I will give overall picture of the periodic classification. What and all we have discussed. That I am going to give first 10 to 15 minutes. Then we are going to solve some of the questions tomorrow and the day after tomorrow, 2 days. We are going to solve some of the questions. Any doubt? Because we have discussed about ionization enthalpy, then we have discussed about electron gain enthalpy, then we have discussed about electronegativity, electropositivity, metallic character, non-metallic character. That means it is done. Yes, chapter is over. Okay, so don't worry. Periodic classification is done. But anyway, tomorrow I will club all these concepts together and I will give overall view about the topic. That will take 10 to 15 minutes maximum. Then we are going to discuss some of the questions related to competitive exams. Okay? Any doubts? And if you have any doubt after this one evening time also, you can call me, no problem. Okay? So you can call me in my phone. You can have a discussion, no need to hesitate. Only thing is you should tell me which college. You should tell that you are from learners, otherwise I will get confused. Okay? Fine. In that case, I will stop the class. Tomorrow we are going to continue. Take care. Bye. Okay.